This is Mrs. Boland with your Unit 6 review. So first we're going to start with the warm-up. Number 1 says find the slope. So just a reminder that the slope is the rise over the run. And I like to say the rise is the y's. So it kind of goes together. The rise is our change in y, and the run is our change in x. And so you can either just look at the y values and say, okay, I was at 3 and now I'm at 7. So I went up by 4. And then the x's, I was at -1. I went all the way through 0, and then I went 5 more. So I moved a total of 6. You could do it that way. You could also plug it into the equation that says I take the second y value minus the first y value, and that gives us 4. And then I take the second x value minus the first x value minus a negative is the same thing as plus. So you can see we get the same answer whether we plug into the equation or if you just say how much did it go up by in y, how much did it go over by in x. All right, and then you should reduce this. You could divide by 2 on the top and bottom and get 2/3. Question number 2, what is slope-intercept form? Y equals mx plus b. And the reason why it's called slope-intercept form is because the numbers that will pop up in this equation are meaningful to us. This one's the slope, and this one is the y-intercept. All right, question number 3 says graph y equals 2x minus 1. And so this is where I begin. And this is my slope, which is m. And then remember, we can write that as a fraction. So if I begin at -1, that's on the y-axis, because when I plug 0 in for x, I get y equals -1. Okay, so that's one of my points that I know works. And then I know that the way that I move m, the slope, tells me it's positive. So I go up by 2 over by 1. Up by 2 over by 1. All right. Question number 4 says determine if the table below represents a function. Okay, so if it's going to be a function, I don't necessarily need it to have a common rate of change. That's if it's linear. But for a function, for each input, it will give me exactly one output. So if you see here, I plugged in a 16 and I got out a -2. Well, do I plug in 16 again? I do. So what I should get out is a -2 if it's a function, but it came out a +2. So this is not a function. Because in a function, for each input that I plug in, I should get only one answer for that input every single time. If it gives me anything different than the first time, it's not a function, okay? And then look, it even happened again. If I plug in 1, I get out -1. If I plug in 1 again, this time I got a +1, okay? Definitely not a function. There's twice that happens. Okay, so we're going to go ahead and look at the practice problems. This one says write an equation of the line. Well, I know I have y equals mx plus b. Well, b, where I began, is -3, so I'm going to put a -3 at the end. That's where I begin. And then my slope tells me to go down by 2 over by 4, or you can even cut it in half, down by 1 over by 2. All 3 of those points are on the line. So if we're going to reduce it, it would be down by 1 over by 2. But if you did the points that were on there, down by 2 over by 4, you could still reduce it and get 1/2. Okay, make sure it's a negative though, because the line is going down. Question number 2 says write an equation of the line. So first we have to find the slope, because remember, we want y equals mx plus b. We need to know the slope and we need to know the y-intercept. Okay, so in order to find the slope, I'm going to see how far did I go over in the y direction. I started at 2 and I ended up at 7. So I went up by 5. In the x direction, I started at 0 and I ended up at -1. So I went backwards by 1. So it dropped, the value went lower. So m equals -5. Well, and then here's the other thing. Anytime they tell us when x equals 0, that value right there is the y-intercept, okay, which is b. So the y-intercept is anytime they tell us when x is 0, that number is where it crosses the y-axis. So I don't even have to do any more work. I can just write y equals m x plus B was 2. Sorry, that's a B, not a 6. Okay. Question number 3 says write an equation in a line. They tell us the slope, and then they tell us it goes through this point. Well, I know that this is M. I know that this is X, and this is Y. So I'm going to plug it into my equation, Y equals mx plus B. So Y was 2, M was negative 4/5, X was negative 5, and then plus B. So first of all, if I have a negative times a negative, that's going to be a positive. And then anytime I have divide by 5 and multiply by 5, those are inverse operations and will cancel each other out. Okay, so I have 2 is equal to a negative times a negative, remember, was a positive 4 plus B. And if I want to get B by itself, I just subtract 4 on both sides. So I get negative 2 is equal to B. We already know M, so now we have enough information to write our equation. So Y equals mx plus B. And remember that when B is negative, instead of writing plus a negative 2, it's a little bit better just to write minus 2. All right, question number 4 says write an equation of the line. I was trying to say find. Write an equation of the line. So in order to do that, I usually have my students just switch it to an ordered pair. Remember, this is just telling us that when we plug in negative 3, the value we get out is 2. When I plug in negative 5, the value I get out is 6. So really, I just have 2 points there. So I would want to start by finding the slope. So the slope says, how far did I go up in Y? Well, if I was at 2 and I went to 6, I went up by 4. If I was at negative 3 and I went backwards 2 more spaces to negative 5, that's negative 2 because the value is getting smaller. And so 4 divided by negative 2 is negative 2. Well, now I don't know the y-intercept because we don't know when y is equal to 0, but we can find it. Remember, we just start with y equals mx plus b. We pick one of these points. I'm going to choose this x and y combination. Y is 2, m is negative 2, x is negative 3, and then plus b. So now I'm just going to solve it. A negative times a negative is a positive. That's going to give me 6. So 2 equals 6 plus b minus 6 minus 6. So negative 4 equals b. And then I can finally write my equation. Y equals mx plus b. Okay. That was a difficult problem. That one took kind of a long time to do. All right, question number 5 says, write a linear equation with the given characteristics. So perpendicular, remember perpendicular means 2 things, that we have opposite slopes. One of them's positive, one of them's negative, because remember they have to cross through each other like this. So if one of them's going up, the other one has to be going down. And then we also flip it. And flip. Okay, so if I'm going to take this slope, I'm going to switch it from a negative to a positive. And this right now is 8 over 1, so I'm going to switch it to 1 over 8. Okay, once you get what m is equal to, we're going to ignore the rest of that equation. We're done with that equation. This is the main thing that I need from that when I know that it's perpendicular to a certain line. Okay, well then I need to go through this point. So I'm going to plug it into y equals mx plus b. Remember, this is x, this is y. So 7 equals 1/8 times negative 16, and then plus b. So 16 divided by 8 would be 2. And then because this is a negative times a positive, it's going to be negative. So 7 equals negative 2 plus b. I'm going to add 2 to both sides. So b is equal to 9. And I know what m is. So y equals mx plus b. Okay, question number 6 says write a linear equation with the given characteristics. It is parallel. Remember that parallel means same slope. So m equals 1/3. And then it passes through. Here's an x value and a y value. So if I have y equals mx plus b, the y value is 2, the m is 1/3, the x is 3, and then plus b. Well, 1/3 of 3 is just 1, right? Those times by 3 and divide by 3 would cancel. So to get b by itself, I would minus 1 on both sides. So b is equal to 1. And I already know that the slope is 1/3. So I get y equals 1/3 x plus 1. Okay, question number 7 says determine if the lines are parallel, perpendicular, or neither. And so right away you can tell those ones don't really look super parallel, but we're going to find the slope of each of these lines just to check mathematically. So this is line A, this is line B, and this is line C. So I'm going to find the slope of line A, which goes down by 3 over by 1. I'm going to find the slope of line B, which goes, it's kind of hard to tell in here. I'm just going to go from this first point to this last point. So this goes 1, 2, 3, 4, up by 4, over by 1, 2, 3, 4, 5, 6, 7, 8. So if I reduce that, that's a half. And then I'm going to find the slope of line C, which goes, and I'm just going to use those points again. So that goes down by 6, over by 3, which is negative 2 over 1. Okay, so do we see any that are parallel? Parallel would be exactly the same. I don't have any that are exactly the same. So there are no parallel lines. But if I'm looking for perpendicular lines, those are going to be the ones that are flipped over and one's positive and one's negative. Okay, so I would say that those two are perpendicular. So B is perpendicular to C. Okay, question number 8 says determine if the given lines are parallel, perpendicular, or neither. This one's even easier. M is equal to 2, which if I make it as fraction is 2 over 1. And then this one, M is equal to negative 1/2. Well, would they be parallel? No, because they're not exactly the same. Could they be perpendicular? Yes, because we flipped them over. One's positive and one's negative. So we would say that they are perpendicular. Okay, question number 9. This is kind of a long assignment, you guys. Question number 9 says, tell whether the graph shows a positive, negative, or no correlation. Well, remember, if the dots show a pattern where the line is going up, we say that it is positive. If they showed a pattern where the dots were all going down, we would say that that was negative. But if the dots don't really show any pattern at all, they're just kind of scattered around, we would say that there is not really any correlation, so no correlation. Okay, question number 11 says the table shows the amount X in dollars spent on advertising for a neighborhood festival and the attendance Y of the festival for several years. So as you can see, the more money they spent on advertising dollars, you can see that the more people are coming to their little festival. So we're going to use Desmos.com to graph this. So I'm going to show you really quickly what that looks like. Oops, I don't know why it was drawing. Exit full screen. Let's go over to Desmos. And we're going to go to the graphing calculator. And then I'm going to hit the plus sign to get a table. And the table will allow us to enter those values. So when X is 50, Y is 40. When X is 10, Y is 55. 1 year they spent 150, and that year 55 people came. Then 280 and 250 and 65. Oh, maybe there's not as much of a correlation as I was thinking. When they spent $300, they got 80 people. When they spent $350, they got 105. And when they spent $400, 110 people came. All right, so you can see we have all these points, but they're nowhere on the graph. That's because they're all out of our domain and range here. So if I click this little zoom fit magnifying glass, it zooms in on the data and shows me, yes, it does have a roughly positive correlation there. And so what I want to do is, so that would be part A. I created my scatter plot in Desmos. Part B says, if you had to describe the correlation, what word would be positive, negative, or neither? I would say positive. So I'm writing that down in my book. Then it says use Desmos to find an equation that models the attendance as a function of the amount spent on advertising. Well, if you want that, you can right here tell it to use the data from Y1, and then we're going to calculate. So I'm going to use shift and that little squiggly thing. It's right by number 1. And then I'm going to just put Y equals MX plus B, but I want it to use specific X data that I already gave it. So I do X1, and then I'm going to go plus B. And so then it puts on a line of fit for us, and use Desmos to find the equation. So we're going to look at the equation, and we're going to say Y equals, instead of M, I'm going to look over here. I'm going to enter this value right here, 0.16. And yeah, 16 X, and then I'm going to go for the Y value, and that's B, so that's for the Y-intercept, and I'm going to round to 2 decimal places, so I'm going to say plus 39.31. Okay, and then it says interpret the slope and the Y-intercept of the line of best fit. The slope here represents how many more people are going to come for each additional dollar. And the way you can figure that out is Y is measured in people, in attendance, and X is measured in dollars. So if I do rise over run, the change in Y over the change in X, Y, remember, represents people per dollar. Okay, so the M would be the number of people who attend for each additional dollar spent. Okay, and then this right here would be the last value, B, would be if we spent $0, how many people do you think would come if we didn't spend any money on marketing? Okay, so that's what B represents right there, is whenever the value, the Y-intercept is always when X equals 0. Well, what does X represent? Dollars spent. So that 39.31 represents the number of people who would attend if $0 were spent. Okay, and that is it. I guess I'll just toggle back over one more time just so you guys can see. Sorry, there's that line through it. I don't know what happened there, but it looks like I drew all over it. Anyways, it should, here's your equation, Y equals 0.16x plus 39.31. And then here are your words here for the slope and Y-intercept. Sorry again for the doodles on there, but that is it for your Unit 6 review.